So I think the definition from Wikipedia is that the command line interface is a mechanism for interacting with a computer, operating system, or software by typing commands to perform specific tasks. So they look like that. You are all familiar with them. I remember that about almost 20 years ago or 15 years ago, Bill Gates said that this funny prompt will disappear from the computers, and in Windows 7, not just the DOS prompt is there, but also PowerShell. So probably we will see these funny interfaces for the next decade too. So I think we have lots of command line interfaces. These are the ones I usually use, and I think that they deserve once a presentation because especially if you work in batch mode, this can be very useful. I hope that you will find it after the presentation and you will agree with that opinion. So I think we should go live. And the first thing I would like to see is not really a command line, but we will use Marvin View to display the results sometimes, because we can pipe the output of the command line commands to display molecules in Marvin View. The command is very easy. You just type mview and the file name, which can be a single file, like in this case, or can be a file which contains more than one molecules, an SDFile or a SMILES. And if the file contains not just molecules but some properties as well, this kind of table view of Marvin will appear. But these command line tools have lots of switches or flags which can influence the behavior of these little programs. The grid bag is a Java origin name, which if you append this hyphen grid bag to the same command, you will see another layout of the molecules. So Marvin View started to display in a matrix-like view the structures. So let's go toward the real command line tools. To more convert.
Can I ask a question real quick? So
sure.
How do you pipe stuff in? So if I've got a SMILES file and I just want to pipe that into,
okay.
How do I do that?
Yes, I will show it immediately when we calculate something, and we will pipe for example, conformers, and we will pipe the results there, and you will see that it will show the molecules. Okay. Actually, this can be influenced a lot of the ways you can how many columns and rows are displayed. So from command lines, the first real command line tool is MoConvert, and MoConvert is a simple file conversion tool. So you can have one single or multiple input files, and for example, we can convert caffeine, which is a MO file, to MRV format, and the -O is caffeine MRV. It just ran through, and if we display the caffeine MRV, we will see this is the MRV format, is an XML-like. And let's do that. Let's pipe it for Pat. MoConvert MRV. Instead of the output file name, which is specified with -O usually in each command line tools of ChemAxon, we use this pipe character mview, and the last hyphen is a tricky one. In the beginning, I always forgot. You have to open a hyphen after mview to display the input as well. And you can pipe anyway. If you use command line tools, you can pipe them one after another. This is the beauty of these command line parameters and Unix. Actually, MoConvert knows a little bit more than file conversion. It has some basic molecule modification switches as well. For example, it can aromatize or dearomatize compounds. For example, SMICE, by definition, contains. I will get rid of this. SMICE, by default, contains molecules in an aromatized format. So the aromatic bonds are there. In MDL, from mole files, are single double bonded. So it's the calculate format. So we now here we convert to SMICE format all of the mole files. So asterisk.mol files in this directory, and the output is SMICE, and we aromatize all the bonds and remove explicit hydrogens. So mole convert, after the file format we want to convert to, we have some commands which work, and you see that here the aromatic bonds, the aromatic rings are represented with aromatic bonds. A little nice thing that you can even generate JPEG, PNG, and other images using mole convert. So you can convert a molecule to an image. Now we convert to JPEG, and there are plenty of options about from the resolution, the size of the image, and the background color. And now with this, Mitsu converted it to a JPEG file, and now he just shows the JPEG which was generated. It's an image. At the moment, MonConvert is not able to batch convert, for example, an SDFile to a series of images. Until we support that, there is, on our forum, there is a little program which can do this task, and you can download it from the forum. Tamás wrote some code. I would be glad to see it in MonConvert as well, and in many of our output formats. Okay, the next one is CxCalc. CxCalc tool is the main interface to all of our calculator plugins. So if you want to know what kind of calculations are available, as usual in all command line tools with -h, you can have it. The less piped, it is piped to less, which helps you to display pages, not to run out from the screen. So here here is a typical ChemAxon help page. If you go down, please, some more. Here are all of the calculations which are available, and you can accessible via CxCalc. Just go down. There are plenty, and yes, that would. And you see the one plugin provides lots of calculations. Okay, so let's calculate. What if we are interested in on the options of one calculation? For example, we can how can we see the log-d parameters? We CxCalc log-d, and now we can see the precision, method, weights, anion, cation, pH parameters, and plenty of others for a specific function. So with CxCalc, you access lots of calculations from the single interface. Let's calculate, for example, the pKa of a molecule, or more than one molecules. All right. All right, sorry. It was my fault because I printed MRV on the... here you can see the pKa values of the input structures in a kind of table-like form. It has a header, has indexes on the left. So what if you want to just get the row values? We have a switch which means no indexes and no headers. So we can calculate the log p values of these same files. Okay, pKa. All right, thank you. These are the pKa values now, but no index or header. If a calculation provides a single value for a molecule, then we just have a column of the here, in this case, the log p results. So let's see some more from these calculations. So we calculated a numeric value of one or more numeric values for molecules. But we can calculate molecules from molecules. For example, is it possible, to view first the Marcus MRV file? This is a Marcus structure, a single Marcus structure, which contains lots of variables, variable positions, R groups, list atoms, link nodes, and even R groups within R groups. So it's a quite complex file. You usually go to Marvin to enumerate this library, or, okay, thank you, or you go to Instant JChem to enumerate, but you can do it from the command line. And you save the generated members of this Marcus library to a file, to an SD file, or we can pipe it directly to Marvin view and see what are those structures which are described by this library. Here, we say that CxCalc, we just turn off these headers and indexes. The name of the function is random Marcus enumeration. We just specify that only 50 members should be generated now. And we specify the input file and pipe the results to MView. Yeah, you have to take care of the characters because it's sensitive. And now we see the entire Marcus library in a single screen. The 50 random enumerations of this library. Similarly, you can calculate the lowest energy conformers. It is again a calculation in which we generate molecules from other molecules, and we can display the molecules in a grid, the conformers in a grid backlight, this matrix layout view. This is the CxCalc, the name of the calculation, input file, pipe it to Marvin view, and we specify a Marvin view switch here. The minus is missing probably by the end of Marvin view. Yeah. Lowest energy conformer, in this case it's no S. All right. No, this is the, yes, the Mac thing. We should see here a Marvin view somewhere which continues the calculations in the background. So if you move it, sometimes the size of this thumb is changing. So here are the conformers. It is also possible to pipe conformers to Marvin space. So it's just the next tool to accept the output of the previous input. We have had lots of talks about naming today. We have a SD file, and we would like to calculate the names of the structures in this SD file. And we would like to save these names into an SDFile field. So let's practically, we save the input file to an SD file and append the name to a field. With this -t, you can specify the SDFile field name in which the calculated values should be stored. CxCalc will use a default name if you don't specify it. But you see in the output, we just get the molecules and all of the UPAC names generated in a separate field, which is called name. We won't try all of the calculations which were displayed in the help, but we can try to combine them. This is the field of chemical terms language, so in which you can create some expressions by the combination of calculations of these predictions. In this first example, we just calculate the number of non-heteroatomic rings by using the evaluate command. The evaluate command is the interface for these chemical terms expressions, and after -e, you can specify in a string the ring count function minus the heteroaromatic ring count function, these two numbers, of the input file, and let's see what we get. For each entry in that input file, we get the number of non-heteroaromatic rings. This was a silly example, I admit, but we can calculate, for example, Lipinski's oral drug likeness filter in a similar way. So evaluate -e, and now the expression. Oh, this won't be an easy one. The mass of the molecule should be less or equal than 500, and you can combine with these logical and or operators. The log P should be less or equal than 5, and the donor count similarly less or equal to 5, and acceptor count 2. And we hope that nothing is mistyped. All right. Now the input file name. Perfect. It's running. So the 1 is true, 0 is false. Actually, what I like the most of all of these command line tools is the searching interface. GC search. GC search is something what we can use with databases as well and files. So you don't need to install a database engine if you have some input files and you are looking for and you want to perform a substructure search. Naturally, it doesn't have fingerprints and all of the optimizations of databases. But if your file contains some 10,000s of structures, the core graph matching will give you results in a reasonable time. For example, in this case, GC search -q is followed by the query and the target after, which is a NCI file with 25,000 compounds, and we just pipe the results in Marvin View. You see, you can immediately see the first results, and it runs in the background. Yes?
Jeff, be careful with that, because there's characters in smarts that will be interpreted by the shell. So if you try to do a recursive smarts and you try to do a not with an exclamation mark,
yeah,
that gets interpreted by the shell.
Yep.
I always tend to use single quotes for those rather than double
yes,
quotes,
very good point.
Changes the shell interpretation.
Absolutely, very good point. I also use single quotes in cases when we have some smart characters. Luckily, in this simple structure, it is not. But it's very true that when you use single quotes, you don't have to escape these at characters and exclamation marks.
No, you still have to escape the exclamation mark even in single quotes.
Really?
Yeah.
We have a -n, which means not, as an option,
Yeah,
but
in recursive smarts.
yeah, not in all cases. Yeah, that's true.
Save the smart into a file.
Into a file,
And
yeah.
use it with the file.
But we're lazy people. We don't want to save files.
But
Everything else is
you told that you use another software because you don't like command line and you use it. Yeah, you use it.
I love it.
All right. Okay. This was a substructure searching. Now with -td, we set the search type to duplicate search. So we searched these chlorobenzenes in this database, and we found one. And also, we can have a similarity search, but let's just skip it because we don't have much time. We can also count molecules in a set. For example, we can count molecules which contain nitro in this NCI set, which is the -TC, and we specify one form of the nitro, which actually is a standardized file. So this ionic form is everywhere, and -Q is missing. Yeah. Oh, it's all right. Okay, so we should print out the number, those molecules which contain the number of those molecules which contain nitro. So in this 25,000, there are about 2,000 molecules in nitro groups. This is quite useful. If I don't use TC, we can get the molecules themselves. We can also combine chemical terms expressions with the search. So we can use GC search and use this -E and append even Lipinski rule of 5 to get the molecules which are drug-like. Or now Miklós calculates, just retrieves those molecules which are carboxylic acids, in which the carboxylic acid pKa is according to the given expression. So you see, we are still in the command line, and we have lots of flexible options. And these are, we piped it into Marvin view, and we get these carboxylic acids. Let's ignore the reaction search. Reaction search can also be done with GC search, and it works even there is no JChem base behind. How did you close it? All right, no problem. We will just display then the simple ones. A standardizer, which is a tool which can convert molecules by a list of actions. These actions are not just contain aromatize and remove explicit hydrogen, but also can contain specific transforms and others. So we can use standardizer to aromatize, but maybe it's more interesting to remove the counter ions with standardizer of the input file. It's better if you type it in, yeah. Standardize in SDF. Oh, sorry. Okay. Is it possible to show the slides?
Sure.
That would be the easiest in this case. I think we have 2 slides of what I would like to show. So, for example, we can expand with standardizer aliases. We can convert aliases to groups. So you sometimes see aliases like phenyl, which is not a contracted group, and you can convert them to abbreviated groups. Or this last one is so nice, I'm sorry that we can't show it. It will just strip everything from your molecules and will return you all the ring systems. We don't have time, so it's better if you just show the slides, if possible. And please, the next slide, please. You can use reactor from the command line. So react, you can specify here a reaction file name or a reaction smarts or smirks. And here is the input molecule, and here is the product as a printed output. What is really nice, that since we understand UPAC names as an input format and can generate them as output format, I say react biosmart esterification 2-hydroxybenzoic acid with acetic acid, and output should be the name, and we get aspirin. So that's real nice. And if you pipe aspirin into Marvin view, you will see the structure. So I like that. And I'm not sure whether I wanted to show more about this, but I know that I'm out of the time. So thank you very much for your help, Mitsu, and for your attention. So if you have any questions, I would be glad to answer.
Well, first, let's give György a hand. Thank you. Questions?
Is there, those of us who are chemists and not computer people, is there a spreadsheet that has all what we call the magic command line summarized somewhere?
I don't think that we have a central page for that. We have, for each tool, we have so, for example, if you go to the reactor page, the command lines are there, but we don't have this summary page. It would be good. Maybe this first presentation of the command lines will help us to make some.
Yeah, and just with one example.
Yeah.
So we can follow that example and then use this.
We will do it.
Fantastic.
All right. Thank you.
Okay, any other?
Behind you.
Is there a way to store the results of a calculation in the SDF output file as a field?
Yes, it is possible. You can specify the name of the field you wish if you want, and then all of these calculations are there.
And you could demonstrate it earlier.
Yes. Actually, the printout of the slides are in your brochure, and there is an example in that. Unfortunately, I couldn't present everything what I wanted in this short time. Oh, yes. All right, it worked. It's more interesting with a larger library, and you get just the epoch names. It's nice. Thank you very much.
Okay, any last questions? Nope, let's give him a hand.